So equations and inequalities involving absolute value. So what I'm going to do is I'm going to consider solving the absolute value of x is equal to 3 and kind of show you really what that actually means. So if you're looking at a number line, really what this is asking how far, x and 0 are from 3. So this is really the distance between x and 0. So if I have 0 over here, I have 3 on this side. I also have negative 3 on this side. So the distance in both cases is the x values, 3 and negative 3, are a distance of 3 away. So that's really when you ask this question, you're really figuring out what x values would make that true. So if the absolute value of negative 3 is equal to 3, or I should say, the absolute value of 3 is equal to 3. So what we get is we get two answers here. We get both of these answers right here, 3 and negative 3, will be 3 units away from 0. So therefore, our solution set, x is going to be equal to the solution set we have minus 3 and also 3. So another way of saying that, x equals negative 3 or x equals positive 3. So without showing any more distances, we just know that one way to think about it is the absolute value is always going to make every number inside positive. So that's why the absolute value of negative 3 is positive 3, and the absolute value of 3 is also positive 3. So we'll start doing maybe a couple more. So what if we have, say, the absolute value of x is equal to 5? What if I ask us to solve this? So solve A, the absolute value of x is equal to 5, and then B, let's ask the absolute value of x is equal to, say, negative 4. Try to solve both of these. Well, we know that the absolute value is always going to make numbers positive, so the values that will make this true would be, x is equal to negative 5 or x is equal to positive 5. So that's kind of a way that we can drop the absolute value signs. Is you're kind of used to doing this with the square root of something squared, that when you square root both sides, you always get plus or minus that number. So in this case, you get plus or minus, well this number here, assuming this number is positive. And we can check, so we can check. The absolute value of minus 5 is indeed 5, and the absolute value of 5 is also 5. So both of those work. So this is our solution set. And a lot of times you'll see they'll simplify that. You'll see a solution is the solution set minus 5 and 5. They mean this. Now, if I ask you for the values that would give us a negative 4, you might think, well, what about negative 4 and positive 4? So let's just kind of see if this is true. So x is equal to negative 4 or x is equal to positive 4. But when we go back and check these things, let's see, the absolute value of negative 4 is, well, positive 4. But I need this answer to be a negative 4. Just like this, I wanted these answers to both say 5. I need these answers to say negative 4. That's not true. Also, the absolute value of positive 4 is equal to positive 4. So there's really no way to get a negative out of an absolute value. So the absolute value of something is either going to be 0 or bigger. So really, these things don't work. This thing actually has no solution. So this has no solution. So we'll make this a little bit more complicated with some of the other ones. So if I ask us to solve, so let me pause it, we'll come back with some other examples. So if I want to solve these two, say the absolute value of x plus 4 is equal to 7, and then this equation, the absolute value of x minus 1 minus 2 is equal to 8. In order to solve these absolute value signs, you have to isolate the absolute value, which this is already done. The left-hand side has already been isolated. So what I know is what's underneath this is either going to be a negative 7 or a positive 7. So whatever is underneath it is going to be negative 7, or whatever is underneath it is going to be positive 7. What happens to be what's underneath is going to be this, this x plus 4 is equal to negative 7, or this x plus 4 is equal to positive 7. Again, if negative 7 is underneath here, the absolute value of negative 7 is 7, and if 7 is underneath here, then the absolute value of 7 is equal to 7. Now we can solve both of these equations. So, subtracting 4x is going to be minus 11, or x is going to be equal to 3. So again, a lot of times you'll see a solution set look like this. Now, similar over here, what we have to do is we have to isolate the absolute value sign. So isolating the absolute value of x minus 1. Adding 2 to both sides, you're going to get 10. So now, in order to drop the absolute value signs, you know you're going to have whatever is the other underneath the absolute value could either be 10 or whatever underneath this absolute value is going to be positive 10. So either negative 10 or positive 10. Then we solve for x in both cases. So adding 1, x is going to be minus 9, or x is going to equal 11. So we get our solution sets of minus 9 and 11. Now remember what this means just on your number line, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You have this solution point here, which is negative 9, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This point here, this 11. You have those two solution points is what this means, so negative 9 or 11. So we will do just a couple more. Let me pause it, please. So again, we're just kind of complicating this a little bit more. Very similar equation to what we had for part B. So what we have to do is isolate the absolute value. So I'm going to subtract 8 from both sides. So I have the absolute value of y plus 5 is equal to negative 6. Now this gets back to that second equation we did where we had an absolute value which is equal to a negative number. And I know that that's not going to be true. You know, whatever's underneath this thing is, wherever I plug in, the smallest is going to be a 0 all the way to positive numbers. So this is going to have no solution. Sometimes you'll see a book like this for no solution. Similarly, we're going to have to isolate the absolute value before I can solve for x. So add 2 first, divide by 7 next. This really has the same form as like 7x plus 2 is equal to 16. So you'd solve this by adding 2 and then dividing by 7. So, you know, in order to isolate the x. But what we're trying to do is we're trying to isolate that absolute value. So very similar, we're going to have to subtract 2 first. So 7 times absolute value of 3x is equal to 14. Clearly I've created some nice problems here because these are not always divisible, but the absolute value of 3x is going to be equal to 14 divided by 7, which would be equal to 2. Now, since this is a positive number, I know it's going to have a solution. So what's inside can be negative 2, or what's inside the absolute value could be positive 2. So we'll get x is equal to minus 2/3, or x is equal to 2/3. So this is, you know, your solution set. All right, so we'll move on to inequalities. So if I were to solve absolute value inequalities, something in the form the absolute value of u is less than c. Well, we have this form. If the absolute value of u is less than c, then we have solutions that u is going to be less than c, or u is going to be greater than negative c. So it's going to be really in between your negative c and your c. So if you look at your number line, what we mean by that is this is negative c and this is positive c, that the solutions are going to be in between these. So the way I kind of remember this is if you just drop the absolute value, you see that this is the first piece that you get. And then we know that we're going to get the negative as well, but when the negative is going to flip the sign, so instead of doing that, I like to say u is greater than negative c. So you can see that these are equivalent. But when you drop the absolute value, you get exactly what you expect. But also when you get the negative, you're going to have to flip the direction of that sign. So if I want to solve the absolute value of x is less than 3, what I know is that the solutions are going to be bounded between negative 3 and positive 3. So this is going to be a solution set is going to be minus. Actually, let's do it the way I kind of explained it. That we already know when you drop the absolute values, you're going to get u less than 3, and, or intersection, you're going to get the opposite. So you're going to get negative 3 for u as well, but you're going to have to change the direction of that sign, so it's going to be greater than negative 3. So in order to be both greater than negative 3 and less than 3, greater than negative 3 would be this way, less than 3 would be this way. So the intersection of those, the intersection is going to be from here to here. So we'd say that this is going to be the solution set. X is it's all x, such that minus 3 is less than x, which is less than 3. Or if you want to put this in interval notation, we say minus 3 to 3. Parentheses be an interval notation, meaning that you're excluding the 3's. If we want to solve some that are slightly more complicated, let me erase and I'll come back. So if I want to solve something a little more complicated, again, we know that we have to isolate the absolute value sign. So the absolute value of 2x minus 6 is going to be less than 8. So now I know that this is a less than sign. We're going to have two solutions. You're going to have, the 2x minus 6 and positive 8. You're going to have that 2x minus 6 and also negative 8 and statement because it's less than. Now you drop it, you're going to get the correct sign, but the opposite is going to flip the sign, so this is going to be this way. So now when we solve these, I'm just going to have to add 6 to both sides, so x is less than negative 2, so x is going to be greater than negative 1. And here, adding this 2x is less than 14, so x is going to be less than 7. So we know that we're going to be bounded between, negative 1 and 7. Open circle, open circle. Now it is possible that you can have closed circle as well. What if they say less than or equal? Well, if it's less than or equal, nothing really changes except what you're going to do is you're just going to include these endpoints. So instead of these things being open, these things will be closed. So you'll get the solution set minus 1 to 7 brackets meaning closed. Or you can say x such that minus 1 is less than or equal to x, which is less than or equal to 7. We usually prefer our integral notation because it's so much quicker. Just knowing that brackets mean equal. So we'll do the greater than next. Now if I want to solve an equation of the absolute value of u is greater than c, what I know is the right-hand part, when I drop the absolute values, you're going to have u and c, but the sign's going to be in the correct direction. And then when you do the negative c in your u, you know it's going to be in the opposite direction, so this is going to be this way. Now this is an or statement as opposed to an and statement. So less thans are and, so we're talking about intersections. Greater thans are or, so we're talking about unions. Because what we're going to get is we're going to get negative c and positive c. We're going to get solution points that live on the outer edges. So here to infinity, here to infinity. So what we could say is this is the same thing as minus infinity to negative c, or we can say union c to infinity. So if I want to solve something like the absolute value of x is greater than 5, what we know is we can, when we drop the absolute values, you're going to get this with the correct sign. And when you have the minus sign in your x, you're going to be in the opposite direction, so it's going to go this way. Now this is an or statement because we're talking about greater than. So when you look at these endpoints, you can see that this is going to go minus 5 and this is going to go positive 5. So we're going to be at these ends over here, so this way and then this way. So we can say our solution set is going to be minus infinity to minus 5 open because there's a less than. If you have an equal sign, you just close it. Union or 5 to infinity. So I'll pause it and do a couple more of these, or maybe one more of these, and maybe some general ones. All right, so let's solve these two. This is a special case, but let's finish with the greater than. So we know we're going to isolate this absolute value. So the absolute value of 2x plus 3 divided by 4 is going to be greater or equal to 1. So I know that when I drop the absolute value signs, we're going to get the same direction, the same sense of the sign, and or statement because it's a greater than. When I drop the absolute value signs and put the negative 1, we know it's going to go the other direction. Now, in order to solve for x, we still have to multiply both sides by 4. So 2x plus 3 is greater or equal to 4, and then 2x plus 3 is less than or equal to negative 4. And then, subtracting 3, 2x is less than or equal to negative 7. So x is going to be less than or equal to negative 7 halves. And subtracting 3, 2x is going to be greater than or equal to 1. So x is going to be greater or equal to 1/2. So we know when we're looking at our solution points, we have our solution sets, a negative 7 halves and positive 1/2. We know this is an or statement. It's going to be closed this direction, closed this direction. So we get a solution set that is going to be minus infinity to minus 7 halves closed, union, or 1 half to infinity. Now there's one other special case I wanted to show for absolute values greater than is what happens if I ask you the absolute value of 4x plus 3 is greater than negative 3. Well, what we know is that absolute values will always spit out numbers that are 0 or positive. So this is always true. No matter what number you pick in here, it's always going to be greater than this negative 3. So our solution is going to be minus infinity to infinity. Everything works. And just like a quick kind of verification, like say x is equal to, I'm just going to pick a random number, let's say minus 4. So plugging that in, the absolute value of 4, minus 4 plus 3. So this is minus 16 plus 3. So this is the absolute value of minus 13. But it doesn't matter. Whenever you take the absolute value of a negative number or any number, it's always going to spit out a positive number. And indeed, 13 is greater than negative 3. So this will be true no matter what x value you put in there. So this is just a quick check to show you that one of those points work, but they all work. So this